All right, another integration technique that we can learn is integration by parts. This works when other techniques don't work, which is really handy. It's actually really good for when you have products and those products aren't, one factor of the product isn't a derivative of the other, okay? Because that's when we have U substitution. But if that's not the case, we want to use integration by parts. So here's what you'll be given. Okay, you'll be given some integral. It won't have U's and V's in it. It'll have X's. Okay, but you're going to assign one part of that to be a U and the other part to be a dV. And then what you're going to have to do is you've got your U and dV, okay, whatever they are, you're going to have to take the derivative of the piece that you designate as U to get a du. Don't forget to add your dx onto this. And you're going to have to integrate the part that you designated as dv to get a v. And then you're going to fill in this part of the form. So you're going to take u times v and subtract the v du, the integral. And then you're going to have to integrate that, which could be a u substitution. It could be one of your trigonometric inverses, or it could actually even be another integration by parts. Okay, so there's a couple guidelines that'll help you when you're choosing which parts to be u and which to be dv. You want the dv to be the more complicated part, or the one that you can see easily fits into one of your integration rules. Okay, so if you see something that looks like an arctangent or an arcsine or an arcsecant or an ln function, anything like that, you probably want to make your dv. You want to make that the part that has a derivative that's simpler than what you started with. Okay, so like u squared would be x squared would be a good candidate to be u, because when I take the derivative of x squared, I get 2x, and 2x is a simpler function than x squared is. Okay, so let's look at one example. I'll do a couple more after this. In this example here, I've got two parts. I've got the x to the fourth, and I've got the ln of x. Well, looking at the ones that are going to have an easier derivative, the derivative of ln of x is 1 over x. So that's a really easy derivative. So I'm going to have that be my u, and I'm going to have the x to the fourth be my dv. So I'm going to have to integrate this now to get what my v is. So it's a basic power rule. I raise the power by 1 and drop the reciprocal of my power. And then I fill in the form. So this is what I started with. Now this is actually my v, and this is my u. Okay, because you take v times u or u times v. Order doesn't matter. And then you subtract the integral of v, and this is my du. Okay, now I often forget to put the dx on here, but anytime you take a derivative, there's always a dx that comes along. That's just your chain rule. So the derivative of ln is 1 over x. The derivative of x is dx. Okay, so we've got this, and now I need to finish by integrating this part here. But this is a simpler integration than what I started with, because x to the 5 times 1 over x is just x to the 4. So I'm integrating this, which is another basic power rule. So I can raise the power by 1. This is just a constant, so this 1/5 could come outside here. Raise the power by 1, that gives me x to the 5th. Drop another reciprocal. So I end up with my vu, which is 1/5 x to the 5th ln of x minus 1/25 x to the 5 plus our constant of integration. And that would be our integral. Here's another example out of your book. This is number 26. If you notice here, I don't have anything being multiplied, but I can change the equation and bring that denominator up so that I do have something being multiplied. Now, this is clearly going to be my u, because that's the easiest derivative we have. Okay, so u is x, which makes du 1. So therefore dv is going to be this guy In order to get v, I'm going to have to do a u substitution. Okay, so I'm going to make this inside part u. So I've got u to the negative 1/2. The derivative of the inside part is 3. And I don't have that, so I'm going to need to have a 1/3 out here to offset the 3 that I have to put inside. Now I can integrate with a basic power rule. Raise the power by 1, so I get u to the 1/2. Drop the reciprocal. The reciprocal would be 2 times the 1/3 I've got out here is 2/3. So v is 2/3 u, which is actually 2 plus 3x to the 1/2 power. Now I fill out my form. I'm going to take u times v minus the integral of v du. So u times v, so I get 2/3 x, 2 plus 3x to the 1/2, minus the integral of v, 2/3, 2 plus 3x to the 1/2 du, which is just 1 dx. Finish off the integration with another u substitution. I'm going to have the same value for u. So now I'll raise the power again. So it'll be 2 plus 3x to the 3/2. The derivative of my u is 3, so I'm going to need another 1/3 out in front here to get my du. So I'm going to have 1/3 along with the 2/3 that's already there. So I'm going to have 2/9, 2 plus 3x to the 3/2 plus c. Don't forget to bring down your uv. 2/3 x, 2 plus 3x to the 1/2, and this is minus. That's your derivative. Let's look at another example here. Here I've got 4 arc cosine of x. Now, even though this would be a very easy derivative, it would be 0, I don't know the integral of arc cosine. We don't have a formula for that. So I'm going to have to make this my derivative. That's going to have to be u. So that makes du negative 1, because it's negative u prime, but my u is just x, so it's just negative 1 over the square root of 1 minus or 1 plus. It's 1 minus u squared. And my u is just x, so 1 minus x squared. So therefore dv is just the 4. The integral of that is 4x. So when I fill out my form, I'm going to have u times v, so 4x times the cosine inverse of x, minus the integral of, if I multiply these together, I get negative 4x on top over the square root of 1 minus x squared dx. So I'm going to do u substitution here. U is going to be 1 minus x squared. Du is negative 2x. Now I've got a negative 2x up here because really this could be rewritten as negative 2 times 2x. So I've got the negative 2x. So really I can just take this extra 2 out to the front. So I'm going to have 2 integral of u to the negative 1/2. Okay, because I'm moving this up. Du. Power rule, that becomes u to the 1/2. Drop the reciprocal would be another 2, so that becomes 4. And then bring down my uv. And this is your integral. Okay, so if they wanted to know the area under the curve, and this is your function, and maybe they gave you some values, you'd go through the same steps. You know, you'd plug in the top value, plug in the bottom value, and subtract the two.